name is Mattia Manzati. I'm a front-end developer, but I also do some backend. And I'm one of the co-authors of MobX State 3. And I'm really happy to be here today in the Plone Conf, since Python was one of my first languages I learned. And short story, I learned Python because back in the days, I were playing as a kid a browser game named Travian, which is basically a building game. You have a strategy game, you do something, and you level up your buildings, etc. And it's time-based in order to get resources. I learned Python in order to write a small command line program that automated all my actions in the browser game, but later I discovered that there was an extension for the browser that actually allowed me to use JavaScript as an extension in the browser, so I cheated on Python and started learning JavaScript. And my talk today will be about software architecture, mainly for the front end. Basically, we will speak about MobX and how to architecture your application. But before speaking, let's just have a quick introduction. And let's say, raise your hand if you ever used in production Redux. OK. Who used MobX in production? OK. And did someone try to use React.createContext instead of those solution? OK. So some of you would have done this solution. I hope that you change your idea. And we will see together today why this is not a good idea. OK. Let's start by thinking which are the basic things that every application needs. OK. Every application needs a way to store its application state, because the application has some internal state. And our application isn't a static page, right? So we need some way to change our application state. And obviously, an application is useful if it provides the data you have entered in your application in some way that is useful for the user, right? So for example, if I put in my application a list of invoices, I would like to have the sum of the invoices. And so an application needs to provide aggregated views of the state. But one of the interesting things that every application does is also perform side effects. Side effects that may vary from things like writing to the file system, storing it to a database, or even just asking something to the user, right? Let's have a look at what JavaScript already allows us to do in our application. If we think about it, objects and variables are the perfect solution to hold your application state, right? You can just use a state. And for example, if we have a to-do application, what we can do is use a simple object in order to represent a single to-do with a name property, which is the task you need to do, and a done property, which is a Boolean that defines if we have done this task or not. And obviously, the way to change the state is by using functions, right? With function, we can change the values of our properties and update our state. And up to here, everything seems fine, right? Then we need to provide aggregated views of our data. How can we do that? Well, again, functions can return values. And so we can use function and getter properties, for example, in order to define aggregated views of our data. Here, for example, we are giving back the list of the to-dos that are entered by the user in our application. And the problem is that JavaScript doesn't have a defined way in order to perform something when something happens. In order to do that, usually in JavaScript, you have to do a lot of code in order to put event handlers, event listener, all of those sort of things that make your code a mess. And so here we have reactive libraries like, for example, MobX, which provide this reactiveness in your application and allows you to specify conditions and actions to be run when those conditions are met. So MobX is one of the reactive library we will talk today. And not as the other libraries, MobX hasn't a concept of a stream. a sequence of events, but instead it uses proxies and atoms in order to have listener around your variables and your objects in order to have a feedback when they changes. So the 4 basic units of MobX are observables, which store your application state as we have seen. Those states may change over time, obviously. And one interesting thing is that the observable instance is always the same, as it will be happening for an object, right? You can change properties and values in the object, and the instance of the object will be always the same, right? That's not the case for streams, because if you need to change something inside the value of the stream, you need to provide a completely new stream, right? And with actions, we can obviously change the value of our observable, and those actions can be triggered even from the UI or from side effects when something is met. In order to aggregate our data, we can use computers, which are an optimized way to derive state from your existing observables. And MobX is smart enough to understand which values are used by your computers and only update the computed value when those observables change, right? And those updates are done synchronously. This means that your data, your computed data is always up to date, right? If they were asynchronous, you can reach your computers in a state that is stale, that is not completely fulfilled, right? And that wouldn't be good for your application. Finally, we have the concept of reaction, which is basically the ability to trigger a function when something changes, when a condition is met. And if you think about it, even the user interface is just a reaction of the store state. Because when the values used by your render functions changes, you need to update your user interface. So this is the mirror expression of a reaction. And if you think about it, those 4 elements we have seen have been a successful pattern in the history. Because if you think about it, a software named Excel has been doing this pattern for ages. In Excel, your data is stored into cells, and the user interaction is used in order to update the cell values. Together with formulas, you can provide aggregated views of your state, and the screen updates is basically an expression of those reactions, as we have seen before. But now, let's be more real, more concrete. Let's start with a basic example. Let's start with a classical to-do list, which is what everyone does as a first example with the library. Here we start by defining our application together with React, and we start by defining a React component, a class, which has the state of that component application. We have, for example, the current text, which is the text of the name of the to-do we are writing in, and a to-dos array, which is just a list of the to-dos our application has received up to now. We have actions, which are a way to update our state. So here we can say, for example, that when add to-do is called, what we do is push a new to-do in the to-do array by picking up the current text and saying by default is not done, and then we reset the state of the current text. And as we've seen before, one of the useful things we can do for our user is just having aggregated data. So for example, here we are doing a count of the to-dos which are currently pending, which are not done yet. And obviously, we are missing the most interesting part, which is the rendering of our component, which will use inside of itself the actions and access our data through the views we have defined before. For example, we can see here that we have an input of type text that has as a value, which has as a value the current text of the to we are typing in, and every time the value changes, what happens is we call the setCurrentText method, which will update in our state the value of the current text property. Up to now, if you have a look, we haven't used MobX at all, right? We have just defined a plain JavaScript classes. So Where's actually MobX? Well, MobX can be used with the decorate function, which just takes in a class definition. And what we do is basically map every property definition or method definition to the corresponding block that we have seen before, right? For example, we are saying that current text and to-dos are observables, so they store state. And we are saying that add to-do, toggle to-do, and set current text are actually actions, so they will update our state. And obviously, the pending count will be computed, so will be calculated over the date old in the state. So the first thing you may think about is, well, should I let MobX use, should I use MobX as a state manager for our React component, or should I use React state for the components? Well, in my advice, you should use MobX if you use MobX. And that's because if you think about it, first, MobX is better optimized than setState because MobX will actually re-render your component only if one of the properties used by the render actually changes. And setState, on the other hand, will trigger a re-render every time you call setState. So for example, if you update a property that doesn't matter anything for your render method, it will actually trigger a render, even if not used by your render method. And the other thing is that actually the API is simpler than setState. They are not tied to React at all. We are just speaking about plain JavaScript classes, right? And so that means that it's easier to refactor out from React to any JavaScript framework. For example, one day you are tired of using React and you want to use Svelte or any other JavaScript framework for the front end, well, you can actually reuse the classes you have defined before. And as we have seen for the first slide, there are a few different syntaxes for React. You can use the decorate function as we have seen before, or if you prefer, you can use decorators through the observable decorator or the action decorator or the computer decorator, which will put the definition of the type of the property along with the property definition, which is good because they are collocated, but unfortunately, the decorators are not a standard of JavaScript yet. So as it happened, they may change the syntax a little through different versions. And also, the usage of classes is optional. If you don't want to use classes, what you can do is just wrap around an object together with the observable method, and what we will give back is just an observable object, as you will do by wrapping a class and then creating a new instance of that class. So it's completely up to you which you prefer. For example, if you're writing code for a code base that doesn't support classes because it is an old code base, you can just write objects with no problem. So as we have seen, MobX is completely unopinionated. So we can do basically what we want with MobX. So the question is, when I need to structure my application, which is the recommended architecture I should use by adopting MobX? Well, actually, you can do whatever you want, MVC, MVVM, MVP, or even Flux if you want. What you need to understand first is that MobX is just a reactive data library. So that means that MobX will not put any prescription on your architecture. Redux, on the other hand, is mostly an architecture. And the library is just an implementation of a lot of optimizations in order to avoid re-renders that are not worth it. And so what we can do is just code our application, and then in the end of the day, we will reach our application working. We can add to-dos in our application, do everything, and we are happy because we have done our application, right? But does our application scales? Is it testable? Or, well, is it a great idea to mix the business logic and the UI code in the same part? Well, we need to have a step back, relax, and think a little more. Well, first, mixing business logic and user interface is definitely not a good idea. What happens if later we want to have a new user interface environment for our application? What if we build a web browser application and later in the day our boss came in and says, well guys, tomorrow I want to build a mobile application and it needs to be quick, so it needs to be done on React Native. Well, if you have mixed your code, you will have to duplicate that. That's not good. And what if your boss came in and says, guys, React changed it is license, and someone may remember that something that seemed to happen, and we need to move to another UI framework. And what if performance-wise you need to provide a server-side rendering because you need to start up your application faster? Well, those problems are all related to the problem that when we think about our code, we need to think about the UI as something that we do in the end. So our code should be structured in a way that the UI may changes. The UI may change its requirements, may change its environment. UI is just an afterthought. And there is a great article from Michael Westreich speaking exactly about this argument, and he tells some ways to reach this way of writing code, right? And back to our example that we did before, it's really easy to start and correct our application. What we can do is just pick all the code that was messing with the application state and put it in another class, right? For example, here I create a new class named store and I put here all of our state-based computations. And then in the end, we end up with two different classes for our simple application. One is the store, which manages all of the state of our application, and one is the React component, which given a store just renders the application. Well, now the problem is that we need to link in some way our application store with the user interface, and there are plenty of ways to do that. And for example, in React, what we can do is just pass the store as a property of our React component, right? That will be pretty easy. That will be reach all our needs. But there are few better ways. For example, we can use provider inject, which is two ways of providing a store to our application and injecting a store into our component. And this is better than in using a prop because first you don't have to pass manually your store to all the child components. It will be done automatically by the React context. And also it allows you to change the store implementation in your test, which made our application more testable than the one we have written before. And we have also only one point of injection of our store into the views, and which is perfectly great because in the top rendering method of our application, now we have only that method injecting the store. So going back to our application structure, now we have basically two blocks. One which is the huge one that holds the entire application domain state. It modifies the application state, it has the business logic, calls eventually any API, implements the view for the actions, and also aggregates the data for the view. And on the other side, we have that small React component that just renders the view and eventually calls the action over the store, right? Well, that's definitely better than before, but the problem is that here we have too much things. Can we split that block in something smaller? Well, first, we need to acknowledge that every application has a domain state. And the domain state of your application is usually the domain of your application. We are speaking before about a to-do application, so the domain of your application is a to-do. But if we are speaking about a shopping cart, for example, your domain will be the products, the orders, the customers. So basically, you can describe the domain state as the entities and the relation, you can usually acknowledge which is your domain state by looking at what is persisted over the application usage. Everything that is persisted is usually the definition of your domain state. And that domain state is not tied in any way to the way your UI is defined. Because, for example, a to-do has a name and a property that says if it's done, regardless of the framework of the UI you are using, right? So that makes your domain state highly reusable. So let's go back to our application and try to make our first domain state implementation. Again, what we can do, simply define a new class with a property name and done, and then use decorate in order to says to MobX that the name and the DOM properties are observable, so they will hold the state, and we will remove the definition from our store. And obviously now we need to update our store definition because now we are using classes, so we need to actually create an instance of that to-do domain model class. And here we are speaking about only one domain model to do. But obviously, in your application, we will have more than one domain model. So, for example, you will have users, etc., etc., etc. And one good thing to do is here that we have defined a concept of domain state is usually to couple our domain state models together with domain state actions. And what are those domain state actions? Domain state actions are basically actions that only changes the domain state. So for example, in our to-do application, the domain state of our to-do is if the to-do has been done. And we can provide a toggle method, which is just an utility method over the to-do class in order to just swap the state of the to-do. Well, as we explained before, let's be more real. We have also users, right? Let's say that in our application, when we define a to-do, we also define the user that's responsible for that to-do, right? Well, the first thing that we are asking here is, in that user ID property, what we will put in there? Because we need to express a relation between two entities, right? Well, the discussion here is about having a domain state tree or a graph. What does it mean? It means that if we have a domain state tree, we are not putting any instance reference inside of the properties of our domain state, but instead we are using some values in order to have a reference to the domain state values. For example, the user ID has a number property that references the ID of the user ID. And so that means that the state is usually already normalized, and it's a tree because there is no reference between the objects. And this means that since it's already serialized, we can basically just pick the values from here and send it to our API, for example. They are plain JavaScript objects, so why not? But the problem is that this is really difficult to access because if we have our to-do and we need to reach the user of that to-do, we cannot just type in .user and access the user value. We need to ask the store, give me the user with that ID. On the other hand, if we have a graph, the state is completely denormalized. So that means that inside of the properties, for example, inside of the user properties, we have an instance of a domain model, which is the user, which makes this more hard to serialize, even sometimes impossible because you may have circular references. But on the other hand, it makes really easy to access your related domain state because from a to-do you can just type .user.name and show in your application state alongside of the user, alongside the to-do name, also the username, right? Well, a good news is that we can actually do both because we can define a getter setters over our domain models in order to get the denormalized state value. So we store the user ID as a value, but we can also access the user by .user and find out the user instance. But in order to do that, we need to ask it somewhere to the store. And if we look at this code, the store isn't passed in any way. The problem here is that we need to communicate between stores, right? And there are different ways to communicate between stores. We can use singleton instances and require them, right? It may work, but it's not really testable. So we can use dependency injection frameworks like Inversify.js or other solutions. But the problem is that they are most of the times just an overkill for a simple problem. And so there is an interesting pattern called the root store pattern. And that root store pattern is basically having a store that holds a reference to all the other store. And when creating a store, you pass a reference to the root store. So basically, you are linking all the stores together. And by jumping to the root store, you can access any other store, right? So the root store is a central point of communication for each store. For example, from our to-do store, we can reach our user stores without any problem. It's completely strongly typed if you use TypeScript or other type solutions. As we have seen, it works as dependency root and can also host some variables that are useful for our application. For example, we may have configuration values or a fetch implementation in order to call our API that can be put in the root store without any problem. And as we have seen, it's very, very easily testable. And another thing that we can discuss is that now we can go back to our root store implementation and see that in our to-do, now we can use this.store.rootStore in order to access the root store and get back the user by ID. So with this, we have solved our problem because now what we can do, is just ask again for .user and access the user implementation. But we can also have the user ID. So we are effectively using both the implementation, both the solution. It's both a graph, but also a tree. And as we have said before here, for example, we can also pass to the root store different configuration values. For example, here we are passing to the root store a window.fetch, which is the fetch implementation for our store in order to call the API. And what happens is that in the test later, you can, for example, pass a fake fetch implementation. And that makes your store more testable than before, right? Okay, so now we have split something from our first block. We have now also a block that holds the entire domain state. And we have seen that there is a bit of problem. We have to fetch from the API. And now our state isn't just plain objects. So now we need to convert those plain JavaScript objects to an instance of our domain state classes, right? And this is basically a problem of turning JSON into observable values, right? Because our state is an object tree, but unfortunately is not a plain JavaScript object tree. So most of the APIs, as you may know, provide JSON as an intermediate language. So you need to provide method to serialize and deserialize your application state. And that becomes really a mess and a lot of work to do. For example, what we can do is that in the construction of our domain model state, we can pass in the data which comes from the API. And when we construct the domain model state, we restore the domain model state in that state. For example, here I'm using object.assign in order to copy properties from the data that comes from the API to the model store instance. But obviously in production or in your code of every day, don't do this line of code. You need to perform some checks over the data that comes in. And if you think about it, serializing our domain model state is just as seeing the domain state as another shape, right? So we can actually use a computed value for that. Here, for example, we are defining two JSON method that will return our class, domain state class as a plain JavaScript object together with the property we want to serialize. For example, we may have a date property over our to-do, the date that to-do was created. And when we serialize for the API, it needs to be an isodate string. And when fetched, needs to be an isodate string. But on the domain state, we want to hold it as a date in order to access the date API, right? So here is the point where we can do and perform that conversion. And obviously, the conversion can be a lot of code. So there exists some packages like Serializer, which provides way to define, way to convert your your domain model very easily by just tagging the properties that needs to be serialized and how they needs to be serialized. And one of the problem is that if you think about it, serializing and deserialize may be very memory expensive, because if we have thousands of entities in our application, what happens is that if we call an API that returns thousands of domain state models, we need to convert those thousands of data we received from the API to an instance of classes, and that costs time for the JavaScript language. So fortunately, exists a hidden API from MobX that is called intercept reads, and this API has been undocumented since 2015, I think, but it has been used by the MobX framework and also the other MobX-related packages for a lot of time. And what this API does is basically convert the values you read with MobX while they are being read. So for example, we can have an observable map, so just a map of values, and intercept the values that are being read and convert them on the fly. For example, here I'm trying to set a property with an ID of 1 and a name Mattia, and when I try to get that value by using the intercept reads, we are just appending the .dol value. And this is very useful because with that, we can implement something like a cache. And what happens is that instead of unpacking the entities as they arrived to our application, we will unpack them as we read them from our application. And so when thinking about designing your domain stores, remember that you need to usually provide your data with some lookup ID in order to avoid iterating all the values in your store. And you need to, if possible, hold in your domain store the data as it has been arrived from the API, and then you use intercept lead to just convert that values into the domain state instance as they are being read, and just implement some method that, given an ID, gives back a name without providing any deserialization. Because, for example, you may want to have the username given the ID. It doesn't make sense to convert the entire user object to a domain user object just to get the name property. So in some cases, it makes sense to do that conversion. In the end, we have reached our application with 4 blocks, and we are almost there. There's a thing in here which is aggregating data for the view. Well, aggregating data for the view is just a view-specific task, because we may have different interfaces, for example, for a mobile application and from a desktop application. So the domain state is the same for our application, but we actually need to provide them in a different way. So we can share the same domain state, but we aggregate the data for the view in a different way. So what we can do is just have a part of our application that does exactly that. It takes the data from our store, or our domain store, and it prepares our data for the view. And it also has some methods that handles the communication within the view and the domain state. And one example of this kind of store is, for example, the routing, because the routing is specific for the application. And here we have seen, for example, a simple router that has a page property, and every time we want to open the overview page, for example, we pass in the name of the page we want to open together with the data that the page needs in order to be rendered. For example, we may decode from the URL that project ID and have that property inside of the data object. But the problem is that how we will load that data, because the problem is that, yeah, I will have something that an illegal state in here. We will set the page to something that's not actually have been loaded yet. What if the user actually doesn't have any permission to show that page? We are in an illegal state in here. So what we can do here, again, is use a method from MobX which is called fromPromise, that given a promise returns an object that splits into 3 different states. And here, for example, we are now fetching alongside the page we want to open also the data for that page. So we are skipping that illegal state of having set the page, but not the data. And here is an example of the usage of that page property. And here we can say that basically wrapping your promise with from MobX gives you a method.case, which given the 3 possible states of your promise will switch to a different response. For example, here we are saying that when it's pending, we show the loading test. Where there's an error, we saw error with the error, and where we fulfilled and we completed the promise here, what we do is just render the exact page. So here we have our final solution. As you may know, this solution is pretty similar to something that already exists, right? So what you need to think is that when you are looking for a way to architecture your application, it doesn't depend on the technology you are using. It doesn't depend on the library you're using. Every application needs to fulfill those blocks. And so let's have a quick recap. If you use Redux, you're probably getting paid by hour. Every time you define your store, find always the minimal state. Don't put redundancy into your store. Don't try to have the same property, the same values all along your store. And if possible, derive those properties. Define views over your application store. And as we said before, think as you are building for an UI and for any UI environment, but always experiment and have some fun. And wait, we have been spoken about MobX, right? But yeah, you know Plone, that Volto thing, that Redux thing, right? Doesn't actually met really nicely. And actually, there is a package named MobX State 3, which tries to marry those 2 different packages. And it tries to marry those packages by having predefined data shapes, which we have seen before. They are basically our domain state models, right? And it also provides automatically serialization, deserialization of your models, which we have seen is one of the problems we encounter when defining your application domain state. And also based on that automatically serialization, deserialization, we can also build things that by default aren't available on MobX, but can be implemented in MobX 3. For example, we can provide data traveling, time traveling, and that is based on having a serialization of the entire store, recording the possible state of our application into a list. And when we want to travel back our state in the application, what we do is just restore that application state. And also, any MobX State 3 store is also a valid Redux store, right? So that means that you can write your component for Volto in MobX and the MobX State 3, and then use the as Redux store or as Redux reducer in order to integrate that inside of the Volto architecture, right? No problem with that. And I want to end up in here by having some reference at interesting articles and projects in here. And again, thanks for your time and have a nice day. Any question?
So about the root state pattern, it's nice, it's useful, but if you are trying to build a library that you want to distribute, and then people are going to use it into their own project, how do you manage that? Can you declare the root state easily in the library and use it from the calling package?
The thing is that if you think about it, if you're defining a library, your root states just need something, right? A substate of the entire root state needed by the application. And one thing that is very interesting that we have seen one root state and then the store for every entity of our domain application, and there the domain model for our entities. But what can happen is that, for example, a library developer, what can do is just provide a root store that accepts as a parameter another root store. So the library root store will have only the things that are needed by the library and are provided by the library, and that can be very nicely be integrated inside of the root store of the user of the library. Not sure if I answered your question. Okay.
Any other question? Curiosity? Anything?
Okay.
Okay.
Thanks again for your time.
Thank you, Mattia.